So actually, we let t equal to sine square x. Okay, and then this equation just becomes 16 t squared, right? Because here you have the t equal to sine squared, then the sine to fourth is equal to t squared. Okay, so now this equation becomes the 16 times the t squared minus 16t and then plus 3. So now we have the one quadratic equation. Okay, and this one we can factor. Okay, we can factor this polynomial, and if you forget how to factor this polynomial, you may directly use the quadratic formula, right? So right now let me show you how to factor this polynomial. So you factor this leading coefficient. You have to use the trial and error, right? So try for a few times until you get the right factoring. And then for the constant 3, you may write this as the product of -3 and -1. Okay, so now you can form such a cross multiplication for here, -3, -1 here. Do this cross multiplication, and then you have the -4 minus the 12, and then you get -16. And this is just the coefficient of this middle term. Then you use the numbers in the first column, okay, to form the fourth linear factor, and use numbers in the second column to form the second linear factor. So right now we have the 4t minus 3 and times 4t minus 1 equal to 0. So now we can solve this equation for t. We have the two solutions. So let's move to the next page. So the first one is t equal to 304, and the second one is t equal to 1/4. And we need to do the back substitution, right? Here we know we have the t equal to sine square x. So right now we have found the solutions for t. Then we need to replace t by sine square x and get the corresponding equations for our x. So we have the sine square x equal to 304, or we have the sine square x equal to 1/4. Okay. And from this first equation, we have two resulting equations. So we just take the square root of both sides, right? So now let's begin with this first equation. And this implies we have the sine x equal to plus minus the root of 3/2, right? So now let's first deal with the sine x equal to root of 3/2, and let's from here we first find the inverse sine of the root of 3/2, and we know this is the pi/3, right? And then you use the pi minus this pi/3 to find another special solution, which is between the 0 and 2 pi. So you have the pi minus the pi over 3. Then you have the 2 pi over 3. So these are the two special solutions between the 0 and 2 pi. And in this way, you can get the general solution for this equation. You have the x equal to pi over 3 plus 2k pi. Or you have the x equal to 2 pi over 3 plus 2k pi. And this is the, okay, let me mark this as 1. This is the first case when the sine x is equal to root of 3 over 2. Now let's deal with the sine x equal to negative root of 3 over 2. And then, in this case, we first find the inverse sine of the negative root of 3 over 2. We have solved this before, right? So we know this is equal to the negative pi over 3. Okay? And from here, we can find the smallest positive solution, which is coterminal with this negative pi over 3 by adding the 2 pi to it, right? So we add the 2 pi to this negative pi over 3, and then we have the 5 pi over 3. And another special solution can be obtained by pi minus this negative pi over 3. So that is the 4 pi over 3. So by now I found the two special solutions to this equation. Then we can get the general solution. So the general solution in this case is x equal to 5 pi over 3 plus 2k pi, or you have the x equal to 4 pi over 3 plus 2k pi. Okay, so this is the two cases corresponding to the sine square x equal to 3 over 4. Now, for the sine square equal to 1 over 4, we have another two cases. So let's deal with this. Sine square x equal to 1 over 4. And then from here we can have the sine x equal to plus minus 1/2. So now let's look at the case 3. When the sine x is equal to positive 1/2, and let's first find the one special solution to this equation. We have the sine inverse of 1/2 equal to pi over 6, right? And then we can find another special solution to this equation. How to find another special solution? Use the pi minus the s, right? Pi minus this first special solution. So another special solution is the pi minus this pi over 6. So try to remember to draw the fig, the unit circle, right? And the unit circle can help you to figure out two special solutions. Okay. So this is the 5 pi over 6. Okay. And then we can form the general solutions. So either x equal to pi over 6 plus 2k pi, or you have the x equal to 5 pi over 6 plus 2k pi. Okay.